Okay, good morning. So today is the last lesson on the CT topic. So this is going to be the last Python lesson this year. So you worked really hard this year, really proud of your progress. In this topic, we've talked about different sorting algorithms. We're going to be focusing on a merge sort today and implementing part of that. We want to use that merge sort algorithm to merge two sorted lists. So that's going to be not the whole of the algorithm for a merge sort, but part of it. We want to have lots of practice. The big focus today is reading data in from a file, a CSV file, a comma separated value file. You need to be able to close a file, and then when we read that in, split it whenever we come across a comma. So CT30 looks like this. We've got some code to begin with, and hopefully all of the questions that you need should be on here. So you don't need any code until question 3. So remember that a merge sort works with a divide and conquer recursive algorithm. With a merge sort, what's the easiest way to show this on here? First of all, you have to split up your data. Let's start with what we've got here, 7, 3, 4. So we've got individual values here. We have to keep splitting it up into two separate values. So we'll split it up into two like this, and then each of those is going to get split. Let's add some extra room so we've got some more space. So we're going to end up with 7 and then 59, or we're going to end up with, 7 and 5 and 9, or we're going to end up with 7 and 5 and 9. Doesn't really matter which one you go for as long as you're consistent. So this is the dividing part of a merge sort. Because I've only got 1 on the left out of 3, I'm going to do the same over here, and then I've got 3 and 4 over the other side. 7 can't be split down anymore. 5 and 9 can be split. There we go. We've only got 1 value, and here we've got more. I'm going to put some extra space in here so that we can draw some little arrows, and then hopefully that's what it's asking for. So the first part of a merge sort isn't actually merging, it's separating. I'm supposed to be holding down control and it should drag things, but Word isn't playing ball. There we go. So I've split all of that up into 2 equal halves. And I'm holding down control to get multiple copies of this little arrow. So I'll leave you to work through the rest. Oh, Word is horrible for this. Seems to kind of jump over to the other side of the screen, but we'll get there. So once you've once you've split them all into individual values, remember a computer can only compare 2 individual values. So we look at 7 down here, and we'll compare it with this one over here, a 7 and a 5, and work out which one is the smallest. Oops, sorry, I've got a 1 there from a keyboard shortcut from recording. It's irritating. And we'll know that the 5 is the smallest because we can compare 2 values at once. I'm just going to make that red so that we know that we've done it. And then I can compare this one with this remaining one. So a 7 and 9. The next biggest one is a 7. So I can mark that as done. And then the final one here is going to be a 9. So these are now in order. And I can do the same over on the right hand branch. Well, this 7 is already sorted. So I suppose, help. I could have just put that down here. And I've done this wrong, haven't I suppose. Because the 7 is on its own, it should be there. We have to sort the 5 and the 9. So they are now all together. And then after that, I'm looking at the first in this list, which is a 7, the first in this list, which is a 5, which is the smallest, well, a 5. And then we remove that from the list, and I'm now looking at 7 and 9, which is the smallest, so it's 7, which is the next smallest, and then 9. I'm going to do the same on the right-hand side. So I've just got 7 on its own here. Now I'm working out the smallest out of 3 and 4. So 3, and it's 4. And then I can compare 7 and 3 to give me 3, and then 7 and 4 to give me 4, and then I'll look at 7. And then finally I need to merge the first one on this side with the first one on this side, which is going to be 3. Notice that all of these are sorted and in order, all of these are sorted in order, but the whole lot is not sorted and in order yet. So I'm now looking at 5 and 4, so the next one is 4. I'm now looking at 5 and 7, so the next one is 5. I'm now looking at 7 and 7, so that's going to be one of those 7s. Oh, why have I got 2 7s in there? Messed up somewhere, haven't I? Oh, I'll put 2 7s up here. So mine is completely and utterly wrong. Your diagram is hopefully different. Sorry about that. Hey, there are 2 7s. Thank you. That's good. So what have we got now? We've got another 7, and we've got a 9, and they are all in order. I know that you think that you can just look at them and say what order they're in, but you couldn't look at a million numbers and say what order they're in, and that's the whole point. This should work, this should scale for any number of values. So we need a definition of persistent. Remember, we're talking about saving files not in RAM, not in your memory, but on your hard disk or on your SSD. Why? Because when you switch the power off, everything in RAM disappears. Everything in persistent storage, non-volatile storage, like your hard disk or your solid state drive, it's still going to be there. Okay, so let's have a look at question 3. You should have the code for this alongside the code for all of the other questions. So we just want question 3. Maybe pop that over here, pop that over there so we can see the question at the same time. It says that we want to amend, that means change, the code to write the contents of the 2-dimensional data structure towns, that's this, to a CSV file, that's comma separated value text file called towns.txt. So if we check on the VLE, we've got the PLS. Remember, you get a printed copy of this in the exam. It's Control F to search for file. And then it tells us that we want to open a file in write mode. So let's have a look at that. The bit that we want to do is this bit. Write your code here to save data. We've got 2 parameters, a file name and a 2-dimensional list, a table, both are parameters, and a parameter is just like a variable that you receive as an input. So let's label what we want to try and achieve. Open the file. If we open the file, we want to close the file. What do we want to do with the file? We want to write to the file, but we want to do that for every value in the data structure. So loop through every value in the table, and then that's going to be indented, isn't it? So that's our sub-goal labeling. That's what we're going to try and achieve. Now we just step through and see if we can achieve it. So we want to open. What do we want to open? This file, and it must be in write mode. Pass in a separate argument W, so it's in write mode. This will then create an object, and return that object, so we need to save that object. We don't need to put that as a global variable because it's a local variable. It only exists within the scope, as in within the area of this procedure. If we're opening it, we should close it. There we go. Then loop through every value in the table. We've got a parameter here called ptable. So for, what should we call it, town in ptable. How do we write it? Well, it's just going to be the file.write. Well, we could use string formatting, or we could just use concatenation. I'm going to use string formatting, but you could just use simple concatenation. Maybe we'll have time to do both. We'll see. Yeah, we'll do both. So I don't know what this data is. It looks like a town, maybe a county, and a population, possibly. I don't know. but I want to show the first thing of the town, index 0, that's going to be like Bournemouth. Then I want to show a comma because it's a CSV file. And the second thing, and then you can't see this, but it's not a problem because you should probably work it out for yourself from here. And then finally we need a \n so that it goes onto a new line, but we've got that as a constant here, line feed. So I'm going to put that in here. Remember, a constant is just a value with a name so that you can use to make your code a bit easier to read, although this is a terrible constant because it doesn't have a particularly useful name. It should be called line feed. I reckon that'll work. So let's check. There is no file called towns.txt, but when we run it, we can't concatenate a string and an int. That is currently an int, so we'll have to concatenate it by converting it to a string first, and hopefully, yeah, it's worked. Awesome. Although it does say the output should have exactly 10 lines, and mine doesn't. Mine has 11 lines. So I won't do that now, but you can put a little if statement on the end to only add that on if it's not the last one. Leave it at that yourself. So let's have a look and see if we can refactor this to be done in string formatting instead. We want to have something like layout equals something, a comma, something else, comma, something else, and then a new line. So then I guess we should, yeah, really good point just made. We're going to define this outside of the loop to make it more efficient. We only need to define it once. Now we can do layout.format and put in all of these, town 0, town 1, and town, 2. What have I done there? So hopefully this should be functionally identical, but a little bit neater. Let's see if it still works first of all, but we're still going to have that 11th line, which is irritating. To get rid of that, I'm going to take that out of this thing here, and I'll make a new variable in here and I'll call it first, and I'll say this is currently the first one that we're doing. Then we can say if first, if it is the first one, or probably better if it's not the first one, we can write that line feed character in. Otherwise, so it is the first value, as in Bournemouth, we can just set first to false. But then regardless of whether or not it is the first value or not, we want to actually put the value in. So let's see if that's worked, and then we can talk through what's happened. Yeah, there we go, we've only got 10 lines here. So how does that work? This is called a Boolean flag. It's just saying either the flag is up in the air or the flag is not up in the air. The flag is up in the air to say that we are currently on the first town. If we're not on the first town, we want to put a new line feed in, but we are on the first town. We haven't written Bournemouth yet. So all we're going to do is say, okay, next time we're not on the first town anymore. Regardless, write all of the information, and then this time round, it's not the first one anymore, so this time we will put a line feed in. It's a little bit more complex, but it should be okay. Right, let's have a look at question 4. So programs needed to load an internal data structure with persistent data that consists of lake names and their areas in square meters. After building the data structure, its content should be printed out in a table as shown here. We've been given lakes.txt and we need to open it and display it. So kind of the reverse of what we've got so far. We've got a file name, we've got a data structure to store all the stuff in. We need to do 2 subprograms. One is to load it and one is to display it. Okay, let's do the loady one first. So let's think about what we want to do. Open the file, which means we need to close the file. Extract each line. Extract each part of each line, store it in the table. Okay, so let's think about how these are related now. For each line, we're going to have to extract each part of it. And then only once we've done that, excuse me, can we store it in the table. Oh no, we want to store each line in the table as well, don't we? So now we can get to the code. What do we want to open? Well, we've got a parameter that tells us that. Thank you very much. This time it's not in write mode, it's in read mode, so we don't need to bother saying it at all. We must, however, store the return value. Why? So that we can close it later. Why? Because otherwise, all of the memory associated with this is going to still be in use, and nobody else will be able to write to that file until we've closed it. Right, so let's go back to our file reading and writing. Surely, oh, they don't put it in the PLS actually, but there is just a read which gets everything. File.read. So I'm going to go for the contents of the file. Again, this is not a global variable, it's a local variable, so I don't need to put it in the global variables part. Its memory is only allocated when this subprogram runs. Its memory is freed up when this subprogram is finished. So that's going to be the whole contents. I guess we want to extract everything, so we can say lines equals contents.split. This time we'll split every time we have that new line character. So contents is going to be a string containing everything. Lines is going to be a list containing lots of different bits of text, as in that'll be the first value in the list, the second value in the list, etc. Right, if we have a list, we can iterate through it. We can have a for loop, for line, singular, in lines, plural. That's our list containing all of them. This is a new variable we've just created for the purpose of this loop. Oops, I've got my indentation wrong. For each line, what do we want to do with it? Well, we want to extract each part. What does that mean? Well, we've got two parts. We've got the name of a lake and we've got a number. I don't know what that number means. Doesn't really matter. Oh, combined area. No, just area. So let's see, name is going to be line square brackets 0. Deliberately putting in a logic error here, see if you can spot it. And area equals line 1. Thank you. So yeah, we spotted what we've forgotten to do here. This at the moment is only going to get the very first character of the line. So it's going to get an L for name, and then it's going to get the second character, which would be an O for the area. I don't want that. I want to get the first value up until a comma, and then the second value after a comma. That's what I want to do. So how do I do that? Well, we need to extract it. So line.split, this time we'll split whenever we have a comma, and I often call this parts, as in different values or different sections or different parts of the line. And then we can say the first item in that list called parts and the second value in that list called parts. We haven't yet stored it and we haven't done the most important thing, so I'll pause it here and see if you can work out what's missing. So we have a global variable that should ultimately store all of the lakes. But that's a global variable. We are going to be passed that global variable as a parameter. So we've got that parameter here. That's what we want to add it to. So we'll do ptable.append. Append means add on to the end. What are we going to add? Well, I'd like to add a list because it should ultimately become a two-dimensional data structure. And that list should contain two things. It should contain name and area. Now, if you were being pernickety about this, you could say, what's the point in extracting that and then using these in here? Why can't we just put parts in here? Because that is a list. But I would argue it would be more readable to do this, especially seeing as this is a real value. So I can put float in here to convert the string that we read from a file into a floating point number, a number with a decimal place. So I think that would be better. The main thing that we haven't done yet is return a value. So we must return the table. Remember, Edexcel really likes us to put return values in brackets. I don't know why. I've asked them. They can't give me a good reason, but they just tend to do it. And our problem is that we haven't done this yet. So that's why we have the error message. Okay, so let's take a look at how we can try and get this last bit working. What we've got so far is reading the data in from a text file into a two-dimensional data structure. And we've implemented this function which returns the list. Although it looks like it doesn't actually return it, it looks like it just modifies it in place. So maybe we don't need to return it because it's not actually doing anything with the return value. What we do need to do though is display the stats. So let's break this down into what we want to try and achieve. Loop through every lake, as in all of these. Display individual lake. But I guess we need to display the titles first, so that should go up here. Titles. Oops. And then finally we need to display the totals. We can't display the totals until we've calculated the totals. And what are the totals? Well, it's just a sum of all of the areas so far. So that would be in here. Update running total. So how do we do that? I guess let's have something for the layout. We're going to use string formatting. Don't know if it tells us how many characters, but we're going to have something for the lake name and then something for the area. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm going to go for about 20 characters. I don't know how many we've got for this, but it looks like it's center aligned possibly. Should we go for another 20 characters, this time center aligned? This one is left aligned. Will it work? No idea. We'll see. Right, to display the titles, we can print, because we're not writing to a file anymore, we're writing to the screen. Layout.format, we want to shove in the lake name. And then we want to put in area. Will it work? Hopefully we should be able to test it now. Yeah, promising. And then we've got all of these. So if we've got 20 characters for each one, we should be able to have that multiplied by 40 to go all the way across. Now my screen is too thin to be able to see them all, but that looks promising. Great. Loop through every lake. Well, how do we do that? This is using a global variable this time. So for lake in lakes, we just need to get used to this idea. This is the variable that we're using to iterate through, and this is the data structure we are iterating through. So plural list, singular individual. Display the individual lake. Okay, how do we do that then? Let's see. Print layout.format. We'll use the same string formatting layout, but this time I want to show the name. And I want to display the area. I don't know what the name and area are yet, so let's find out. Name is going to be from the lake. Oops. The first value in the list. And then the area is going to be the second value in the list. Will that work? Oh, it looks good, but it doesn't look particularly well formatted because we want 2 decimal places for all of them. Ugh, yuck. How on earth do we do this? I can't remember. So let's use the PLS. That's what it's there for. There we go, something like this. Something point something F. So I'm going to have 20 characters, point to F. Will that work? Yeah, you see it's okay, but it's still not lined up very well. And this isn't great because it's... we're going to have to try and change this ever so slightly. We'll have a layout for the titles, and we'll just stick with what we had before. And then, after that, we're going to update it this time. I don't want 20 characters anymore. I want right aligned at maybe 15. I don't know, I'm guessing now. 2 decimal places. Yeah, that looks all right, but maybe a bit further to the left. So let's go for 13. Yeah, looks all right to me. And then all we've got left to do is update the running total. That means we're going to have to declare a variable called total, set it to 0, increase it by area each time within the loop. Oops. And then display it outside of the loop after another one of these. I'm not going to do that. You can work it out for yourself. And then you've got question 5 to work through. Just a reminder, at the very end of the lesson, I would like you please to submit to the VLE. We're on half term 5, algorithms and programming 5. That's where we submit to, please. But we've got 5 minutes left of this lesson first.